Hello and welcome back to Ganesh Institute. In today's video, we are going to take up a topic from probability, and that is how to find probability if or and operators are used. Okay, so let's talk about the basics first. Okay, what do you mean by outcome? Let's say if you throw a dice and you randomly choose any of the options, what do you have? In case of die, you have 1, 2, 3, 4, 5, 6, right? So these are the result of all possible outcomes, right? And hence it is a sample space. So all these 1, 2, 3, 4, 5, 6, what are these? These are actually result of that random experiment which we did, throwing a die. So result of a random experiment is an outcome, and list of all those outcomes is a sample space. Okay, now what do you mean by trial? Let's say if I'm tossing a coin, if we toss the coin, what are the outcomes? Sample space is head and tail, either head or tail, right? So when we repeat a random experiment several times, let's say we do it twice, then the sample space will be head head, head tail, tail head, tail tail. Or we can do it thrice, four number of times, and as many times as you want. So this is what? A trial. Everything which we are doing n number of times, if we are doing it n number of times, then there will be n trials. Okay, so we can say that when we are doing this event, this experiment of tossing a coin, then each trial will result into either head or tail, right? What do you mean by event? Event is basically you have subspace with you, you have sample space with you. Now if you ask that, tell me the probability of getting an even number. Probability of getting an even number. So you know that probability is favorable outcomes upon total number of outcomes. So what are favorable outcomes here? Even means 2, 4, 6. So 3 possible outcomes. And total are 6. So 3 ones are 3, 3 twos are 6. This is the answer for this particular event. This is the event. When you have sample space and you ask for one particular subspace out of it, then you call it an event. Okay. So what is it? Sample subspace of a sample space. Okay. Now, so far, so good, right? Let's talk about some operators first. Let's say I have a Venn diagram here. I have two events, A and B. If I want that A or B happens, so OR means union of events. And there is a formula for union of events, that is PA union B is PA. See, this is PA, this is PB. But see, this part, this common part has been taken twice. So I have to remove it once so that no replication happens. So PA plus PB minus PA intersection B. Okay. Similarly, now this is what? Intersection is what? This common part. So common part is called as intersection. That is when both A and B are considered. So AND operator basically. So PA intersection B is called PA and B. Now let's say I want to have PA complement or A dash. Okay, it is called as A dash also, A prime. So A complement means not happening event A, not happening of an event A. That means you can have everything from this universal set except A. Yeah, so what you will say? You need to remove A from the whole thing. And do you know that probability of happening an event and probability of not happening an event, the sum is 1. Because 1, see, probability is what? Favorable outcomes upon total. If you have, let's say, a bag in which lemon candies are there, so probability of getting a lemon candy if you pick one is for sure there, because you are picking out a lemon candy from a bag which is full of lemon candy. So every single time, always you will get a lemon candy only. So that means favorable outcomes, whatever they are, let's say 50 candies are there. So 50 by 50, that is 1. So this is a sure event, right? But let's say if I want here now an orange candy and I already know that it doesn't have an orange candy. That means, of course, the probability is 0. No favorable outcomes out of 50. So hence we can say that there is one impossible event and there is one sure event. Probability always lies between 0 and 1. 0 and 1 are inclusives. Okay. And let's say if you've got 60% marks in particular subject. So how many marks have been deducted? How much percentage has been deducted? 40%. So that's simple, right? I mean, the sum is always 1. 100%, that is 100 over 100, that is 1. So that's why we are considering this. Okay. So I was at this point that if you have to find out a complement, that has to be 1 minus PA. Because 1 is the total net probability, the sum of all the probabilities. And if you take away A from it, it will be complement. Similarly, it goes with PB as well. Now, if you have to find out PA minus B, what do you do? What would you do in this case? So let's say I have this Venn diagram thing again to tell you. This is universal set. Now you want A minus B. That is, you want A, but that part which is not the part of B. So that means you have to remove what? You have to remove A intersection B. Because in A intersection B is also there, but this is the common part which it is sharing with B. So I don't want that. So that means, can I write it as PA minus PA intersection B? Yes. And have you heard about Demorgan's law? So basically, if I have complement, let's say, and there is intersection sign, so you can put union sign and you can take the overall complement. Why it is so? See, prove it using Venn diagram again. So I have made these two Venn diagrams to see whether these two conditions are true or not. So A complement, that is not A. So this is the one, not A. Anything but not A. Yeah. B complement is not B. So that means not B. Yeah. And you want to have intersection. So what is the intersection where both horizontal and vertical lines are lying? So that is basically what? Except these two, everything has got both lines, right? So I need to remove from universal set what? A union B. Correct. Now see here, right hand side. That is what? A union B complement. That means you can have anything, universal set, but not A union B. That's true, no? Apart from these A union B, you can have everything, which is same as this one. So Demorgan's law state that. Now, why I'm telling you all this, let's apply this in the question. Here it's saying, suppose there is 60% chance that it will rain today, 50% chance that it will rain tomorrow, and 30% that it does not rain either day. Then you need to find the probability for all these cases when it will rain today or tomorrow. Today and tomorrow, today but not tomorrow, and today or tomorrow but not both. So tell me, if it's saying or, that means we have, okay, first up, let's suppose what all the events are. So I'm assuming that A is actually that it will rain today. This is the event. Then I'm assuming B as it will rain tomorrow. These are the only two events which we are having to classify tomorrow. Now, so PA is given to us. It will rain today 60%. 60%, that is 60 by 100, so 0.6. And PB is, it will rain tomorrow, it's 50%. So that is 0.5. And 30% that does not rain either day. Does not rain either day. That is not A nor neither A nor B. Yeah. Okay. If it is neither A nor B, can I say it is A union B complement? Yeah. Let's try this out. First part is we need to find out it will rain today or tomorrow. Today or tomorrow means, or means union, right? This is the first thing which you have to find. So that means PA plus PB minus PA intersection B. Right? Correct? So PA is what? PA is 0.6. PB is what? PB is 0.5. And PA intersection B is what? Tell me, how can we find that? So see, we are given with this part, A union B complement, which is 30%, that is 0.3. So what will be PA union B? PA union B will be 1 minus PA union B complement, correct? That is 1 minus 0.3, that is 0.7, correct? So this is the first answer. Then question is asking, find out that it will rain today and tomorrow, that is intersection. So in intersection, we want this bit. We have already got union, which is 0.7. So let's find this. If you take this, if you bring this on to the left hand side, it becomes 6 and 5, 11 minus 0.7, that is 0.4, right? So this is the answer for second. Now C is saying today but not tomorrow. So probability of today but not tomorrow. Not tomorrow means you have to deduct. You don't want B in it. So PA minus B is what actually? It is PA minus PA intersection B. PA is 0.6 and intersection is 0.4. So this has become 0.2. That is 20% chances are there that it will rain today but not tomorrow. Then B part is what? Either will rain today or tomorrow but not both. So that means either will rain today or tomorrow, but not both. It can rain today or tomorrow. Only A, only B, but not this bit, the common one. Right? So that will be what? Today or tomorrow, but not both. That means only A. That means only A, but not B, plus only B, but not A, right? So this becomes PA plus PA minus PA intersection B. And this becomes PB minus PA intersection B, right? So PA is what? 0.6. Intersection we got as 0.4. So these are 2.8 plus PB is what? 50%, 0.5. Yeah. So 0.5, 0.6, 1.1 minus 0.8, that is 0.3. So this is how you can solve the question related with all these Venn diagrams. I'm hoping that you've got this concept right, and if so, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye-bye.